Today I'm going to continue working on the types of factoring. Now, in the last video, I covered the first two types of factoring, GCF and quadratic trinomial. So I'm just going to continue working on number 3 and 4 types of factoring, the difference of squares, and the difference of cubes, sum of cubes. All right, so let's go ahead and start with the first example. Let's say, as a review, in multiplying, for example, x plus 5 times x minus 5, okay? So here we were given two binomials and we're asked to multiply. We can FOIL this out or distribute the terms, say x times x equals x squared, okay? And then what is x times negative 5? That's negative 5x. The next step, multiply 5 and x, that's positive 5x. And then multiply this 5 and negative 5, that's a negative 25. Okay, combining like terms, we have this x squared. Now the middle terms will cancel away, so we have just x squared minus 25 as the product. Now you can see that the product is a difference. Difference uses minus. Difference of two perfect squares. Okay, so x squared is obviously a perfect square. 25 is also another perfect square. So it's a difference of squares. We call it difference of squares. Now, we get a difference of square product when you multiply this type of binomials. So the x plus 5 and x minus 5, we actually have a sum and difference of two the same numbers, like x and 5 for both of them. It's just one is using plus, the other is a minus. So it's a sum and difference of two numbers, x and 5. So when you multiply a sum and difference of two numbers, then the product we get is a square minus another square, or a difference of two squares. Okay, let's take another example of sum and difference of two numbers. Let's say you have 3x plus 5 multiplied by 3x minus 5. So again, this is a sum and difference of 3x and 5. So 3x times 3x is going to be 9x squared. Now 3x times negative 5 is negative 15x. 5 times 3x is positive 15x. And then 5 times negative 5 is negative 25. Again, the middle terms will cancel out. Okay, so now we have 9x squared. Hold on, I think, yeah, minus 25. So once again, we have this difference of two squares. Okay, so 9x squared is a perfect square. 25 is another perfect square. So difference of squares is the result of multiplying, okay, sum and then difference of the same number. So when we work backward, let's say you're asked to factor, okay, factor 9x squared minus 25. So how do you factor this difference of squares? Now the factors are going to be this sum and difference above here, okay? So what we're going to do here is, okay, one thing that will help is to recognize that this is a difference of squares. And after that, we can just factor each term here into 3x, 3x. And then for the 25, it's going to be 5 and 5. And just want to make sure that one is plus and the other is a minus. Okay, so one thing that will help you factor difference of squares is to first recognize that this is a difference of squares, and then you associate that to the types of factor that we can expect, like sum and difference of that same number, 3x and 5. Okay, so let's say factor, say 16x squared minus 81. Okay, so again, this is a difference. Okay, the difference of two perfect squares. 16x squared is a perfect square. Now 81 is also perfect square. So by the way, what are the perfect square numbers? What are those squares? The smallest positive perfect square is 1, right? Because 1 squared is 1. Okay, what's the next perfect square? 4 from 2 squared. Okay, what about 3 squared? So 9 is a perfect square. What's the next one? 16, okay, from 4 squared. What's next? 25 from 5 squared. 36, 6 squared, okay? 49 from 7 squared. 64 from 8 squared, and so on. So these are the perfect squares. So when you look at this difference of squares, all right, now this is going to be a perfect square variable because x squared is obviously a perfect square. Okay, in the first part of the factoring, I emphasize also that before you do any kind of factoring, like in this case, we're doing a factoring the difference of squares. I mentioned in the first video that you always want to make sure that there's no GCF. So look at the two terms and see if there's a greatest common factor before we do this unique style of factoring for a difference of squares. Okay, so I'm going to go ahead and write 16x squared. Okay, because when we factor this difference of squares, it's easier to, okay, to check the factors for our expression. So 4x and 4x is 16x squared. And for the negative 81, it's just going to be 9 and 9. All right, so one is a positive, the other is a minus. Again, you can FOIL this out completely, or you multiply and check and see if it's really 16x squared minus 81. Okay, so another example for difference of squares. Let's say 81 x squared minus 100 y squared. So that's a difference of squares. So 81 x squared, what are the factors? 9x, 9x. What about 100 y squared? 10y, 10y, one is plus, the other is a minus. Okay, let's say you have 4x squared minus 36. Okay, so this is a difference of two squares. Okay, so this is a perfect square. This is also a perfect square. Now, in this example, there's a GCF between 4 and 36. So we can factor out the 4 first. Okay, always check for the GCF. So this example has a GCF between those 4 and 36. So we can factor out that 4. So we got the 4x squared, and then 4 times what? Okay, 4 times what give you the 36. So it's a 9. Now, after you factor out the GCF 4, now you can quickly check that this is still what? A difference of squares, right? So this difference of squares can be factored into what? X and x. Now 9 is 3 and 3. One is plus, the other is minus. Okay, so we got this complete factors for our difference of squares. Okay, now let's say you skip that factoring by GCF. Say I'm so excited. I recognize this to be difference of squares, so I went ahead and factor it, say 4x squared will be what? 2x and 2x. And then 36 are going to be 6 and 6, plus and minus. Okay, because you didn't do the GCF in the beginning, this is not the complete factor yet, because notice that 2 and 6 can still be factored because they have a common factor too, okay? So you still have to do the GCF. You just have to do it at the end of the process. So x plus 3. Now this 2x minus 6 needed also to be factored by GCF, x minus 3. Now those 2 and 2 should be multiplied together into 4. And now rearrange it, x plus 3, x minus 3. It's a little longer and more tedious to do it this way. So my recommendation is always check for the GCF from the very beginning, okay, before you do the next type of factoring, if applicable, okay? Now, so that's about it for the difference of squares. What about sum of squares? Okay, for the sum of squares, let's say you have, okay, I need to review this first, okay? Let's say you're gonna multiply x plus 5 and x plus 5. Now, x plus 5 is x plus 5 squared, right? Now, when you multiply this x plus 5 by itself, you're going to get x squared plus 5x, then another 5x, and then 25. Okay, so that give us this trinomial x squared plus 10x plus 25. All right. So when I give you a sum of squares, say x squared plus 25, so this is a sum of squares, okay? This is just a short review, all right, because we're going to be making use of this later on. Okay, so let's go back to our sum of squares, okay? Let's say you're asked to factor x squared plus 25. The most typical answers that we get is x plus 5 and x plus 5 for this sum of squares, okay? So after we do some exercises from a difference of squares, we might do this type of factoring for sum of squares, because x squared will be x and x, and factors of 25 will be 5 and 5. Only we have two positives for our product, factor. Now, but when you check, what is x plus 5, x plus 5? Now, earlier we see that this is going to equal x squared plus 10x plus 25. And this is not, okay, equivalent to that x squared plus 25. In other words, that x plus 5, x plus 5 are not the correct factors, okay? So, in short, for any sum of squares, you have to recognize that that is a sum of squares, say x squared plus 25. What else? X squared plus 36. X squared plus 100, okay? So this sum of squares are not factorable. They are not factorable, or you can just call them prime, okay? So we can no longer factor them. So sum of squares, they are not factorable, and they are prime. Okay, so I'm going to end this video and then continue on the sum of cubes, difference of cubes on the part 3 of factoring, okay? So thank you for watching, and I'll see you on the part 3 of this concept.